Everyone, welcome. I'm Dr. Jennifer Gordon and the chair of IAPMD's Clinical Advisory Board. I'm very excited to welcome you all to our professional community webinar, Menarche and Neural Sensitivity to Peripubertal Hormone Changes, Implications for Adolescent Psychopathology. So we have Dr. Elizabeth Anderson with us today. Before we get started with her very interesting talk, I want to give a little bit of information about our organization and go over a few housekeeping points. So to those of you who are new to IAPMD, so that is the International Association for Premenstrual Disorders, we are an international nonprofit organization providing information, support, and resources for anyone impacted by premenstrual disorders. So just want to take this opportunity to put in a plug for our PMDD treatment ebook, which is available for purchase on the IAPMD website. So you can scan this QR code here up on the screen in case you're interested. So this book is the result of years and years of work by the IAPMD team and covers everything you need to know about PMDD and its treatment. We also have another release. So the book Hope was written by Erin Kinghorn. So Erin serves as a member of IAPMD's board of directors and has 15 years of lived experience, of experience living alongside PMDD and has provided direct peer support to hundreds of partners for the past 5 years. So you can scan that QR code. All right. And just to note that all proceeds from both of these books go towards supporting IAPMD's work. Sorry, that's looking a little strange. In 2021, we launched the IAPMD professional community with the mission of bringing together professionals to advance education, accelerate quality research, and create a global network of experts. So for those of you who are part of the professional community, as part of your membership, you'll gain access to regular webinars provided by expert speakers, clinical discussion groups, and other networking opportunities. So before we start the session, we'd like to disclose that any statements that are made by our speaker do not necessarily reflect the views of IAPMD or of the Clinical Advisory Board. And if you have any concerns, you can contact me. I'm going to now introduce our speaker, Dr. Elizabeth Anderson, who is an assistant professor at the University of North Carolina at Chapel Hill. And she will be talking about menarche and neural sensitivity to peripubertal hormone changes, implications for adolescent psychopathology. Please go ahead, Dr. Anderson.
Great, thank you. Thank you so much for inviting me to present today. I'm excited to be back and presenting some new results to the group today. So for today's presentation, I'll be discussing the challenges and opportunities of studying menarche, or the first menstrual cycle, and the neuroendocrine changes during the pubertal transition. So I have no conflicts of interest to disclose, and this research was funded by the National Institute of Mental Health and a Foundation of Hope seed grant. So first, I'd like to start by having you think back to your experience of puberty. Do you remember having a lot of friends and it being a happy time of your life? Or did you feel kind of awkward and insecure, which is definitely more my experience? No matter what your experience of puberty was, I think we can all agree that it was a turbulent time. We can all understand how challenging it was to navigate new responsibilities, a changing body, and evolving social roles, all with this immature brain, especially in regions that are really important for decision making and emotional processing. So puberty is characterized by dramatic reproductive endocrine instability and heightened stress, which all contribute to greater risk for depression, especially in adolescents assigned female at birth. So physical maturation of secondary sex characteristics like breast development and the appearance of acne are probably the most observable signs of puberty, but this is really just the tip of the iceberg. Dramatic refinement of brain networks that are important for top-down regulation of affective, more emotional circuits that develop from bottom up, leaving the frontal networks last to mature and thus most susceptible to the increased stress, which is increasing tremendously during adolescence. Even circadian rhythms shift during puberty, which all contribute to this increased vulnerability to the development of and the emergence of psychopathology. So starting at puberty, but not before, rates of depression are 2 to 3 times higher for females compared with males. And this divergence between the sexes continues throughout the reproductive lifespan. This profound sex disparity emerges abruptly at mid-puberty, about the same time as the average age of menarche or the first menstrual cycle, and continues until after menopause, which possibly implicates sex steroids like estradiol, which is the most potent estrogen. For individuals assigned female at birth, the reproductive or sex steroids, including estradiol, rise with puberty and begin to fluctuate with the menstrual cycle. There's a substantially increased risk for affective illness, particularly depression. There have been influential experimental studies demonstrating that a differential sensitivity to normal changes, but not absolute levels, in these sex steroids during specific reproductive events trigger affective symptoms in susceptible individuals. And there's increased risk with reproductive events that are associated with dramatic hormone changes, such as a decrease of progesterone and estradiol during the premenstrual phase, associated premenstrual exacerbation of symptoms, the withdrawal from high pregnancy hormone levels during the postpartum period, and the wildly fluctuating hormone concentrations that occur during the menopause transition or perimenopause. These all contribute to greater risk for depression. However, until recently, this relationship between hormone changes and affective symptoms had not been examined during the pubertal transition, which is similarly characterized by abrupt hormone changes and increased stress. It's not just the start of the menstrual cycle during adolescence. The pubertal transition is also characterized by dramatic increases in reproductive steroid variability, and these also might contribute to mood disturbances during puberty. So the first step in my examination of the endocrine changes during the pubertal transition was to characterize peripubertal hormone variability of salivary hormone collections, which were analyzed for 14 different ovarian and adrenal hormones using this ultra-sensitive assay method. So in this slide, you're looking at weekly hormone levels of estrone, testosterone, and DHEA for premenarchal and postmenarchal participants. We found that not only increasing levels and variability that may contribute to increased mood symptoms, but we also found that a large proportion of the adolescents in this study were mood sensitive to hormone changes. Using analysis approach that was developed by Doctors Eisenhower, Mill, and Gordon, we found that some adolescents were specifically sensitive to increases, decreases in hormones, or the degree of hormone change, regardless of the direction. But everyone experiences, there was 57% that were sensitive to estrone, 37% sensitive to testosterone, and 6% of our sample were sensitive to DHEA changes. But everyone experiences increased hormone flux during puberty and with the onset of menstrual cycles. So why are some adolescents more sensitive to developmentally typical hormone changes? We then examined recent stressful life events and how they impacted the relationship between the degree and direction of hormone change and more specific mood symptoms and perceived stress. So we found that life stress events unmasked directional effects of hormone-induced mood changes, such that participants with high stress, indicated by the dark blue lines, showed increased mood symptoms with increases in hormones, whereas decreases in hormones were related to increased symptoms in low stress conditions. So menarche, the first menstrual cycle, and associated hormone changes, in addition to the increased stress exposure during puberty, may influence the initiation of psychopathology. My current research investigates the pathophysiological relevance of sex steroids like estradiol and testosterone, and how they change during puberty and how this impacts the emergence of mood disturbances, particularly in adolescents assigned female at birth, and then looking at the dysregulation of brain activity, brain circuitry, stress physiology, and how sleep and circadian rhythms may also contribute to this hormone mood relationship. I use a dimensional multimodal approach to understand the initiation of mental illness trajectories at puberty and what contributes to a high risk versus a low risk profile. So we've discussed what makes this a vulnerable time for the emergence of psychopathology, but I also want to mention that this is an important window for interventions. So I'm constantly thinking about how we could devise new intervention approaches that would target some of these important constructs of pubertal development. So again, the first menstrual cycle is called menarche and typically occurs around the age of 12 in Western countries. This first year post-menarche is characterized by irregular and frequently anovulatory cycles. And just a very brief overview of the menstrual cycle. In adults, the menstrual cycle lasts on average 28 days and can be broadly divided into the follicular phase that ends with ovulation and the luteal phase. In adults, the luteal phase is described to be almost consistently 14 days long, whereas the follicular phase can fluctuate a little bit more. Ovarian hormones fluctuate characteristically across the menstrual cycle, with estradiol having a peak right before ovulation and a second rise in the follicular phase. Progesterone is flat during the follicular phase and rises during the luteal phase. LH peaks right before ovulation. Ovulation is critical in determining cycle phases, not only because it separates follicular and luteal phases, but also because anovulation is associated with different hormone patterns. For example, there's no progesterone rise in an anovulatory cycle. This leads to less predictable hormone concentrations and fluctuations, which is a problem when we want to investigate biological underpinnings of psychopathology in peripubertal adolescents. So we assume that one of the reasons for this gap in research is that there are few guidelines for detecting ovulation status in the pubertal transition. Again, this gynecological stage that's characterized by cycles that are highly irregular and frequently anovulatory. So this project was led by Dr. Hannah Klusman from Berlin. And while some of our participants exhibited the characteristic pattern on this top graph with estradiol, progesterone, and LH across the menstrual cycle, the majority of our participants looked more like this bottom figure with no detectable pattern. So we used a novel algorithm and rating system for detecting ovulation based on an LH peak and progesterone rise. We determined that 43 to 59% of the cycles assessed were anovulatory. Also, menstrual cycle characteristics deviated from the typical adult pattern in really striking ways, including a short luteal phase, approximately 8 days, and a more variable cycle length from 20 to 43 days. A comparison between the standard LH ovulation test and this method revealed only modest agreement, only, I think, 30%, suggesting that methods for ovulation detection, even LH testing used in regularly cycling adults, are not applicable for research with adolescents. So in our first characterization of the changes in hormones across the menstrual cycle, we just looked at how progesterone and estradiol varied between ovulatory cycles and anovulatory cycles. And as expected, hormone patterns did differ by ovulation status with greater fluctuations and variability in progesterone and estradiol during the anovulatory cycles. We are then interested in determining how the ovulation status impacted the relationship between hormone and mood changes. We started with examining individual differences in the sensitivity to daily changes in the urinary metabolites of estradiol, E1G, and progesterone, PDG. And we found that within-person decreases in E1G were related to increases in hopelessness, rejection sensitivity, irritability, and concentration difficulties in participants with ovulatory cycles, whereas PDG change or progesterone changes were positively associated, so increased progesterone with increased mood swings. For anovulatory participants, decreases in estradiol across the cycle were associated with increases in anhedonia only. But if we look at overall mood symptoms, anovulatory participants had greater affective symptoms, particularly loneliness, difficulty concentrating, and mood swings, and overall depression and anxiety symptoms. So maybe these symptom changes are not necessarily tied to daily ovarian steroid changes, but across both ovulatory and anovulatory participants, we observed greater symptom reports or greater symptom severity for most symptoms that we assess during the perimenstrual and early follicular cycle phases. In a recent collaboration with Dr. Gordon, we used a novel method to calculate the synchronization or the coupling between daily changes in hormone change and mood symptoms. So we applied a time-lagged cross-correlation analysis to quantify the within-person degree of synchrony or coupling between hormone measurements and affect ratings across the menstrual cycle. This was accomplished by holding the mood time series steady, which is in the dashed line in this example, and creating lags and leads of hormone levels, which is in the purple and green, across the collection period to compute the resulting correlation coefficients. Compared to previous analysis methods, this method provides a more comprehensive examination of how these two time series move together over time to determine when a hormone change leads to an affective symptom change, or the hormone lead affective symptom lag relationships. So the maximum coefficient corresponding to a lag value, or the time between a hormone change and a mood symptom change, is extracted from the region indicated by this red arrow on the bottom figure. And in this representative example, the participant experienced a maximum increase in mood symptoms the day after a significant change in estradiol and progesterone. This is another representative participant who experienced a maximum increase in mood symptoms 6 days after a change in estradiol and 4 days after a change in progesterone. So in the figure on the left, you can see the purple is estradiol, the green or teal is progesterone, and then the dashed line is the mood across the cycle. So we examined each of these figures on the right, the correlation coefficients, to determine whether the correlation coefficient was significant and extended beyond the red dashed line, where this little circle is highlighting the maximum peak. This participant was ovulatory, but there were no differences in the hormone sensitivity strength between ovulatory and anovulatory participants. So, and just to further characterize the hormone synchrony in this sample, we found that the majority, or the largest percentage of participants, were sensitive to anger, or they had increases in anger and irritability with changes in estradiol and progesterone, followed by mood swings. The lowest, or the symptom that was least sensitive to hormone changes, with anhedonia, or low interest in pleasure, pleasurable events, or things that they usually find pleasurable. And the overall, if we break it down by the different sensitivity profiles, we had 51% were sensitive to estradiol, and 54% of this sample were sensitive to progesterone. So actually more of our participants were sensitive to progesterone. Oh, and I just wanted to mention too, only 31% were sensitive to both progesterone and estradiol. 45% of our participants who were sensitive also had a biological parent with a reproductive mood disorder, including postpartum depression, PMDD, or depression during the menopause transition. So in addition to endocrine changes, the pubertal transition is characterized by the dramatic refinement of frontal brain networks and increased exposure to interpersonal stress. So my research follows a diathesis stress model, where we propose that stress proximal to the pubertal transition or early life adversity may modify frontal limbic networks important for emotion and stress regulation, making some adolescents more susceptible to developmentally typical peripubertal hormone changes. So after determining that a large proportion of our participants were sensitive to hormone changes, the next step was to examine the biobehavioral mechanisms that may predict the strength of the relationship between the hormone changes and mood, or the hormone mood sensitivity. So my career development award, which is in its last year, aimed to address the limitations of my previous work and focus on the menstrual cycle. So the previous work I had, the very first figure of hormone sensitivity, I'd only had weekly hormone samples. And we had both pre and post menarchal participants. So from the adult research, we know that changes in ovarian steroids like estradiol across the menstrual cycle produce windows of vulnerability for affective symptoms, particularly the abrupt withdrawal from the high levels that occurs around menses, late luteal or perimenstrual phases. However, the impact of the menstrual cycle on the changes in mood in the first year post-menarche had not been examined, so we collected daily urine and mood ratings across one menstrual cycle. And we know that female adolescents experience greater emotional and physiological responses to interpersonal stress or peer stress and rejection, which may contribute to their greater risk for affective illness. Social rejection is a particularly salient stressor for adolescents. So at 2 time points anchored to estradiol changes during the late luteal and late follicular and late luteal phases, we examined neural and endocrine responses to interpersonal stress and rejection. We were able to modify the timing of the lab sessions based on the cycle data from our first 20 participants. So in the follicular phase, we administered the psychosocial stress test, the trigger social stress test, to look at cortisol reactivity to a very robust psychosocial stressor. We also collected electroencephalography or EEG recordings during resting state, well, just the brain at rest, emotional affective task, and just viewing different faces, so fear, happy, and neutral faces. During the late luteal task, we administered a social feedback task and then the same EEG tasks. So during adolescence, immature frontal brain regions, important for decision making and cognitive control, are overshadowed by hyperactive limbic or affective brain regions that are engaged during emotional processing and stress regulation. So the increased bottom-up emotional processing and delayed top-down regulation from prefrontal cortex may play a role in this increased risk for psychopathology during adolescence. We're interested in, particularly in my lab, we're interested in understanding the role of estradiol and testosterone on the emergence of adolescent psychopathology, because estradiol regulates all systems implicated in affective illness, including neurotransmission and stress responsivity. These key sex hormones, both estradiol and testosterone, that coordinate the sex differentiation of these frontal limbic affective networks, have a high density of receptors in these same regions, so the frontal cortex and limbic affective regions. And so they're able to help regulate the frontal mediated affective processing during puberty. The frontal networks in particular are undergoing extensive refinement and maturation during puberty, and therefore are particularly vulnerable to the stress exposure and the peripubertal endocrine changes. So in my lab, we use electroencephalography to examine frontal regulation of emotion and affective processing. So just a brief overview of the EEG recording process and analysis process. We can record from the scalp. In our system, we have 32 electrodes. And from the raw EEG recording, we can look at both the time amplitude analysis. So these are voltage deflections that are time locked to the onset of a stimulus, or decompose the signal into magnitude and phase information for different frequencies to examine multiple layers of parallel processing, neural processing, and characterize their changes over time with, again, respect to the task events. So using the time frequency analysis, we can examine event-related changes in EEG power that are time locked to the stimulus presentation. I'll refer to these as the event-related spectral perturbations. I'm particularly interested in theta activity from 4 to 8 hertz because it's associated with top-down frontal processing, and beta activity, which is associated with 13 to 30 hertz and associated with novelty detection, arousal, and reward. Sorry. So we've just started analyzing the EEG data from the 2 labs to compare oscillatory activity between cycle phases. So these are topo plots illustrating the power measured in decibels of the theta response to fearful phases. So the red indicates greater power. So preliminary results suggest a trend towards greater frontal and parietal theta during the luteal phase in response to fearful phase stimuli during that implicit face viewing task. And interestingly, when we look at differences between participants with ovulatory and anovulatory cycles, we found that ovulatory participants had greater frontal and midline theta during the luteal phase compared to the anovulatory participants. So these disruptions in theta oscillatory activity may underlie an increase in symptoms related to the withdrawal of estradiol during the late luteal perimenstrual phase. During the luteal lab, we used a modified social incentive delay task to examine the neurophysiological responses to different types of social feedback. So in this task, participants created a profile, including a picture that we told them would be sent to peer raters to see if they wanted to be friends with them. The number of rejections, so then they received the feedback while we recorded their brain activity. So we had rejection with thumbs down trials. We had positive, like accept trials with the blue thumbs up. And then 2 neutral conditions, like question, I don't really know if I want to be your friend, or not available, the hourglass. So we extracted the event-related potentials that are time-locked to the stimulus presentation of the different feedback types. And we examined, for this analysis, we found that participants demonstrated an increased response for rejection trials during attention orienting ERP components, which is like, for example, this N1, a negative going ERP component, and later prolonged event-related potentials that are associated with the cognitive elaboration and deeper processing of the feedback stimuli, which is indicated by this arrow pointing to P3, which is a positive going component that's elicited between usually 300 and 500 milliseconds after the stimulus presentation. This is a little difficult to watch for very long, but it's a time lapse of the response to the rejection trial. So it kind of moves from the visual, the posterior brain up to the front to process. And then we looked at the theta in response to rejection versus question trials, and we found that both theta and beta were stronger for rejection trials and differentiated feedback type. So we are continuing to examine different ways of looking at the predictors of the biobehavioral predictors of hormone sensitivity. This is the very first analysis looking at the mood sensitivity to testosterone changes. And we found that participants that were sensitive to weekly testosterone changes showed an increase in theta oscillatory activity, more false alarms during the behavioral task, and blunted cortisol reactivity to the Trier social stress test. So these results suggest that an aberrant frontal cognitive control and blunted psychosocial stress reactivity may predict which individuals are more sensitive to peripubertal hormone change. However, this study did not account for the menstrual cycle again, and half of the participants were premenstrual. So we're continuing to look at this in a larger sample, but also across the menstrual cycle. And this is our first attempt at looking at the neural sensitivity to estradiol changes in our new sample. We found that estradiol variability was associated with greater friendship stress or perceived friendship stress, in addition to frontal theta in response to rejection. And there's this interaction that suggests that reduced theta in the context of high estradiol variability predicted greater friendship stress. So in conclusion, I've shown that peripubertal adolescents have substantial hormone variability, but not all adolescents develop affective illness. Further, these biobehavioral mechanisms, including increased theta, underlying emotion activity, and blunted stress responsivity, have also been shown in adolescents with severe psychopathology, suggesting that these mechanisms might be predictive of a high risk phenotype or profile. Ultimately, this research will be important in identifying early risk factors and potential treatment targets for adolescent psychopathology during a critical window for intervention efforts. So sex differences in internalizing and externalizing disorders that emerge during puberty, as we pointed out. The current research, however, was limited by only including female adolescents and using a cross-sectional design. So future projects will include both male and female adolescents to examine longitudinal developmental trajectories of psychopathology and the influence of sex steroids, including both estradiol and testosterone. So I recently received funding by the Foundation of Hope, which is out of Raleigh, North Carolina, to start this objective, which I refer to as the AMPed project. In addition to collecting weekly salivary hormone samples for the full hormone panel, including testosterone and estradiol, we're testing a mobile health app that is designed to improve coping skills and emotion regulation. So really targeting the frontal cortex or the frontal neural processing. We only have data from 27 participants so far, so stay tuned for that. And with that, I would like to thank particularly the participants and their parents for being involved in this very intensive project. All of my collaborators, the Nerd Lab at UNC, Zert Laboratory that assayed all of these samples. And I will be happy to take any questions.
Well, thank you very much. That was very interesting. So in the audience, if you have any questions, you can put them in the Q&A right now. But I have a few questions I can get started. Can you talk a little bit more about testosterone and I guess how does it change across the menstrual cycle, and maybe a little bit more about like the relevance in adolescence? Like, why is this something? I think, at IPMD, we talk a lot about estrogen, progesterone, testosterone doesn't come up so much. So if you can kind of give a bit of.
Yeah, I would love to. So I first became interested in testosterone because one of the largest longitudinal studies, the Great Smoky Mountain Project, found that testosterone was the best predictor of depressive symptoms in female adolescents compared to estradiol and progesterone. And I found that in my research, again, testosterone was emerging as a significant contributor to mood dysregulation, and it was the one that came out as being most predicted by the oscillatory theta changes and the blunted stress response. And so I continued to explore how testosterone may be contributing or differentially contributing to symptom expression in the pubertal transition. I will say I don't have the grant that I'm trying to get next is looking at testosterone across the menstrual cycle. We don't know how it changes, besides that it's highly variable during the pubertal transition. But I don't have daily testosterone levels now. But in adults, it follows a similar pattern. It does have as estradiol. And it has a diurnal rhythm as well. So it peaks in the morning and falls during the day. But relatively little research has actually been done to look at the relationship between testosterone and mood. There's older adults, and it's been most typically associated with aggression, but that's really the only symptom that it's studied. So I think it'll be really interesting to continue this examination of how it's impacting mood during the pubertal transition.
That's really interesting. It reminds me of a webinar we had on PCOS. So it was actually a speaker from possibly UNC, if I remember correctly, and they were talking about mental health, and they were talking about GABAergic neurosteroids specifically, but With
Yeah.
PCOS, we know that testosterone can be elevated, and it's been hypothesized to explain why they're at higher risk for depression, anxiety.
Yeah, that's a really good point, and something that I've considered. So PCOS isn't diagnosed this early, but it's something that I'm interested in exploring in my in future studies.
Great. So there's a question in the chat. I'm wondering if you have looked for cases where different symptoms show different patterns of change in relation to steroid changes.
Yeah.
Like I guess different profiles, sort of. Mhm.
Yeah, so we've started looking into the the differential patterns of hormones contributing to different symptoms. Um, right now, it looks like in this particular sample, um, there like besides the hormone sensitivity patterns where we see like estradiol and progesterone more strongly associated with changes in anger, irritability. It doesn't seem like there's actually a difference between estradiol and progesterone and their contributions to mood symptoms. In other words, um, it looks pretty um, like both progesterone and estradiol contribute greater irritability and anger, and then mood symptoms. The only one that we found that was only symptom that was predicted by progesterone more so than estradiol was anhedonia, which is inconsistent with what we've studied in other reproductive transition events. But this is something that I'm really interested in future studies and adding in. Um, oh, I guess, sorry, I'm not answering the question correctly. Um,
So I'll read it out. So more on different psychological symptoms showing different patterns of change. So depression showing one pattern of change, anxiety, a different pattern of change across the cycle or in response to the same steroid change.
yes, so in all of the symptoms that we've analyzed so far, they all peak during that early perimenstrual and early follicular phase, and then they dissipate throughout the cycle, which is very different than what I expected. I was hoping to have like maybe rejection sensitivity during the late luteal peaking, or like having stronger symptoms during the late luteal with um, maybe irritability and anger peaking during ovulation, or I didn't see any of that. It was really all symptoms um peaked early in the cycle, and then were lower throughout the rest of the cycle, which I think is kind of unique um to adolescence, and something that I'm excited to explore from. Did that answer your question? Okay, good.
I was wondering, the adolescents that you recruit, what are you looking for a particular, are you seeking people who experience premenstrual symptoms, or like what does your advertising material look like?
Uh,
And
um So I started by not restricting based on mental health diagnosis or family history. I just included everyone and found that the majority of my participants were could have been diagnosed with depression. I mean, it was striking how high an average depressive score was. And so I haven't really had to like widen my inclusion criteria. I think that um this particular project started during COVID, and following COVID, and well, I mean obviously continuing past COVID, but I mean it's true that what we see in the news, I mean the adolescents are really struggling, and I think I haven't had to like increase my recruitment for other diagnoses. I think it's been like I have a really wide range of symptoms, and um I collect screening questions about their parents' hormone history. and I ask them whether they think they're hormone sensitive, which is really interesting because the majority of them do think they're hormone sensitive. But that's not an inclusion criteria. Sure.
I'm just curious. I have never done research in adolescence, so it could you talk a little bit about um, the methodology or like the methodological implications of this, variability in what the menstrual cycle looks like. Um, you're looking at hormone levels daily in some of the studies. Is that kind of the level of detail that you need, like in order to
Yes.
really capture what's going on across the cycle?
Yeah, there are a lot of methodological challenges in analyzing the menstrual cycle in adolescents, and um, we ask a lot of our participants. So we do have the daily urine collections. We started with 3 times a day EMA mood collections, but that was really challenging once they all went back to school. So we do a longer evening survey, which has improved compliance, and we have a lot more information because I think the other struggle with studying adolescents is um, their ability to actually interpret how they're feeling. A lot of them don't understand when we say like anhedonia, for instance, or even rejection sensitivity. I think is one of those things where it's hard to explain, and all of the self-report measures that we use don't quite capture what we want them to. And so part of we've been really striving to take a little time and explain how these self-report measures work, so that they can actually understand what they're reporting every day and how important it is, because we know these change. And so sometimes I think the data so far could be like, because we don't see like a whole lot of variability in symptoms across the menstrual cycle. It could be because they're not accurately reporting their symptoms. And so actually last time I gave a presentation to IAPMD, I had the suggestion of adding parent report. So I actually do, the last couple years of the study, we've done weekly parent reports, particularly for anger and irritability. Um, if they if they know that their child is experiencing greater interpersonal stress. So that's been really helpful. It seems actually they're pretty consistent reporters in that way. So at least we can kind of say that maybe they're understanding the job at hand. But in addition, in addition to the daily assessments, we have weekly surveys where we can go into a little bit more. Like we complete the entire CESV, or the clinical or the depression symptom assessment and stress assessments, um, and a lot more on friendship stress, because that's something I'm really interested in, rejection. So we get a lot of that. And then the labs, we do the full battery of um, everything you can think of.
Mhm. There's another question in the chat. Have you tried looking at cyclical changes in hormones before menarche?
Yeah, so the first project I did, well, no, I guess not cyclical changes. We started by looking at 8 weekly assessments just to characterize variability. And it's interesting that in that particular project, the premenarchal participants were actually more sensitive to hormone changes than postmenarchal participants. And I don't know if that would be replicated if we did across 28 days, but that's something I'm really excited to explore in my next grant, because I want to do a longitudinal examination um, and really start right at mid-puberty, premenarchal, and track them as they go through the transition.
Very cool. I'm just really curious. I don't want to uh, burden you with too many questions, but I'm
No,
curious
not at all.
what the plan the EMA? What sorts of things are you trying to capture with that versus
Yeah. So my research has really followed the high top model, like the dimensional approach. So I have questions. Um, I've tried to, well, this is probably not the best way of doing this, but I was really struggling to find EMAs for adolescents. So I've been pulling like subconstructs of validated surveys. So on on like social anxiety, um, irritability in two different ways, both with the brief irritability and from the inventory for depression and anxiety for adults. Some of the ill temper piece. I have emotion regulation and coping. Because that's another part of the AMPed project that I talked about at the end. I've incorporated that into the cycle analyses. I have a lot on rejection, and I try to do that more in real time. Like, if you experience rejection, fill out this short survey, and nobody was doing that. Even if I offered like additional incentives, they did not want to do that. So that's been a tricky one to assess. Um, are there any like specific ones in mind that you were thinking of?
just when I'm interested in the interaction between, external stressors and, their perception of those stressors. And I
Yes.
mean, it's tricky to get self-reported objective stress,
Yes.
right? 'Cause
Yeah.
when we're looking at daily ratings in people with PMDD, what counts as like a stressor that would warrant sort of removing that row of data versus actually their perception of that stress is
Yeah.
impacted by their current mental state. So anyway,
Yeah. No, I do. I try to get at particularly academic, family, and peer stressors daily. And then they do a more extensive stress, like, well, perceived stress scale weekly. Um, and then like peer victimization and some of the other reports of interpersonal stressors daily. So I try to incorporate stress, even though, like you said, it's really challenging.
mhm.
And that the parents also report the stress of their child. So I think, and I haven't looked at that yet, but maybe that will help um, in that report, the self-report of stressful events.
Well, thank you so much. This was really, really interesting. And sorry, the formatting's a bit off. So we value your feedback, thoughts, and insights. Please consider scanning this QR code and leaving your feedback about this session. Also giving us suggestions for other things that you'd like to hear about. And if you want to access our website and resources, you can scan this QR code to the right. All right. Thanks, everyone. Thank you, Dr. Anderson, for a very
Thank
interesting
you.
discussion. Bye, everyone.